Hey guys, this is the second episode of the GraphQL course with NestJS. In this video, we are going to implement the authentication and authorization in GraphQL with NestJS. So first, we are going to create the sign up mutation for registering a new user. Then we are going to implement the sign in mutation, and inside we are going to generate the token for the user. Then in the next section of this video, we are going to protect the queries and mutations of our GraphQL endpoint with the JWT, and then we are going to create a custom param decorator for accessing the current user from the JWT token, so we can easily get the authenticated user in our protected queries and mutations. And finally, we are going to enforce the role-based authorization with our GraphQL queries and mutations. In the next episode of this course, we are going to cover the advanced TypeScript techniques and paginated queries. And in the next video after that, we are going to clone a blog project with NestJS and NestJS monorepo and using the GraphQL as a glue between these two projects. So welcome to the Socrative channel. And if you're ready, let's dive into the authentication and authorization in GraphQL with NestJS. So let's get into it. All right, guys, I open up the VS Code and this is the NestJS application that we have created in the previous video, and we have set up the GraphQL inside this application, and we also created 4 entities in this application: post, profile, tag, and user. So let me show you the diagram of the relationship between these 4 entities. We have the user entity. Each user can have 1 profile, and also each user can have multiple posts. And here we have another relationship between the post and tag. Each post can have multiple tags, and in the same time each individual tag can be associated with multiple posts. So this is going to be a many-to-many relationship. So we have these 4 entities in our application. We have configured the type ORM in this application. And now in this video, we are going to focus on adding authentication and authorization into our GraphQL endpoint. So if you haven't watched the previous episode of this course, I highly recommend you to first watch the previous video, because in that video, we have covered the fundamentals of setting up the GraphQL in NestJS. And as I said, in this video, we are going to add the authentication and authorization to our GraphQL endpoint. So if you're ready, let's get into it. So in the first step, we need to go to the user entity. And here, as you can see, we have an ID, username, email, and also the role of the user. So we need to add a password field in the user entity. So here, I'm going to add it, password. It is going to be a string. And then we are going to mark it with the column decorator. It's a type ORM decorator, and set nullable to true. And then we are going to mark it with add field decorator. Actually, I think we don't want to return the password of the user from our GraphQL endpoint. So we just create this column with type ORM in our user table. And now let's open up the terminal. As you can see, it's done. The application is running. And now we are going to create a sign up mutation for our application so the user can sign up or register into our application. So in order to do that, I'm going to create a auth module. So let me just turn off the dev server and let me clear this up first. I use the Nest CLI for that, NestGMO, and then I'm going to call it auth. Okay, so this is going to be our auth module. Now I'm going to create a GraphQL resolver inside it. So NestG resolver, I'm going to call it auth, and then --nospec, because we don't want to create the test file for this. Okay, now let me just create a auth service here for the auth module. So NestJS and then auth --nospec. Okay, so let's close this off. And now we can go to the auth module here. I go to the auth resolver, and now we need to create a sign up mutation for this resolver. So now let's create the mutation for the sign up. I use the add mutation from the NestJS/GraphQL. We have covered the mutation, resolver, and queries in the previous video, so we don't want to explain them again in this episode, and we just use them here in this episode. So this mutation is for signing up a user or registering a user. The return type of this mutation is going to be a user entity. So I put the user entity here, and then here we need to create a function for this mutation. So I'm going to create a sign up method here, and it should take the argument. So I use the @args decorator, which comes from the NestJS/GraphQL. And then here we need to specify an input name. So I just name it input. And now we can have the input in the parameters of this function. Let's set its type to the create user input that we have created inside the user module. So here, let me put the body of the function. And as you can see, we didn't have declare a name for this mutation. So it actually get its name from the corresponding function. The name of the mutation is going to be sign up. All right, so let me go to the create user input. So the client must provide a username, email, and a role. So we want to remove the role from the create user input. That's because it actually doesn't make sense to ask the role of the user in this mutation. So all users in the first place are going to be normal users, and then the admin of our application can choose a user to be admin and update the role of that user. All right, so we just get the username, email, and also we need to get the password of the user. So here in this input, we're going to have a password, and it is going to be a string. Use the @field decorator from the NestJS GraphQL, and now we can enforce some validation here. For example, we can say that it is going to be a string, so is string, and let's have a minimum length this password. So we set the minimum length to just 3 characters. In a real world application, you need to have much more complex validation for your password. You can include special characters, minimum length of 8 characters or more. But in this tutorial, let's take it easy. All right, so we include the password field in our create user input, and now we can use it inside the signup method of the auth resolver. So here we are going to create a register user method in the auth service class and then call it from here. So first we need to inject the auth service in this class. So I use the constructor here, and we're going to say private read only auth service and set its type to the auth service class. Okay, let's put the body of the constructor, and now here in the signup method we can use the auth service. So just return auth service that I'm going to create a method inside it. I'm going to call it register user and pass the input object into it. All right, let's declare this function in the auth service. Okay, now let's go to the auth service here, and here we are going to create a user object based on this input and insert it into our database. So first we need to inject the type ORM user repo. So use the constructor here and use the @inject repository. Okay, specify the user inside it, import it from the user entity file, and then we can have the user repo, so private user repo, and set its type to the repository class, and in the generic specify the user entity. All right, let's put the body of the constructor, and now we can use the user repo here in this class. But before doing that, let me go to the auth module and register the user repo here. So I use the import section. It is going to be a list, and then call the type ORM module that for feature and pass the user entity to it. All right, so now we can use the user repo here inside this module. Let's get back to the auth service. And before moving forward, let me emphasize that some of you guys might prefer the Prisma. And since we are focusing on authentication and authorization in this video, it doesn't matter what ORM you are using with this project. By the way, if you prefer Prisma, in the clone project that I promise you to upload after this course, I will use Prisma for that project. So if you're a Prisma guy, don't worry, in that video I will use Prisma. Okay, so now here, get back to our register user method. Let me first mark it with async, okay, and let me just remove this error. So now we can use the type ORM to insert the user into our database. But before doing that, we need to hash the user password. So for hashing, I'm going to use Argon2 package. So let me quickly install that, npm I Argon2. You can also use Bcrypt for hashing, but I prefer to use Argon2 because the algorithm of the Argon2 is newer. Okay, so here first let me hash the password. So I'm going to say const hashed password, and we're going to use the hash function of the Argon2. So make sure to import the hash from the Argon2. It's an async function, so let's wait before it, and then we can pass the input the password. So in this way we can hash the password of the user, and then we are going to create a new user. So const new user and set it to user repo the create method and pass the input to it. So I just spread the input here, and we're going to override the password. So we're going to set the password to the hashed version of the password, and also set the role of the user to just role the user. So all of the user, as I said at the beginning, are going to be normal user. Okay, now we can just simply save the new user into our database. So here, just return await this the user repo that save function and pass the new user to this API. Okay, now let's get back here into our GraphQL resolver. So as you can see, we just call the register user function of the auth service, the function that we have just created, and then pass the input here, and it will create the user for us. So now let me just run the application again. All right, so now we can test this sign up. But before moving forward, let me go to the user module here and user resolver. As you can see, we have a mutation for create the user. So let me remove this mutation for creating the user. And here we just now have one mutation for creating the user or signing up a user, which is going to be the sign up mutation. All right, so let's save this and open up the terminal. All right, the application is running. Now let's go to the GraphQL playground. And now let me use the sign up mutation. Okay, we need to pass an input, and inside the input, we are going to specify the username. For example, let's say something like Sakura, and for the email, just put sakura23@gmail.com. Okay, and then we need to specify a password. So for the password, just put 1 through 3, and from the returning object, we are going to return the ID of the user and also username and also the role of the user. So as you can see, we cannot select the password of the user, and that's because in the user entity, we did not decorate the password field with the @field decorator. Okay, so I just want to select the role of the user and let's run this mutation. Okay, so the user with the ID 15 is created in our database. So here you can see the username is Sakura, and this is the email, and the password is going to be 1, 2, 3. So that's it for the sign up mutation. And now we can go ahead and create a sign in mutation for our GraphQL endpoint. So if you're ready, let's get into it. All right, so before moving to the code, let me get back here to this diagram tool. And here I'm going to show you what is the process of signing in a user. So the client send a login request to our application. We're going to create a GraphQL mutation for the login or sign in request. And then it is going to be sent to the auth service. And inside this auth service, we are going to run a user validation. It means that we are going to look through our database and check the username and password of the user to see if such a user is existed in our database or not. And if that's the case, we need to generate a token for that user. So we are going to use the JWT service of the NestJS, and from the auth service, we are going to issue a token. It means that we are going to call the JWT service, and with that, we are going to actually generate the JWT access token for the user, and then send it back to the auth service. And here in the auth service, we need to create a auth payload. It usually contains the ID of the user, the role of the user, and the generated JWT access token for that user. So we're going to include these three inside a auth payload object and then send it back to the client. So this is going to be whole signing process in our application in a very abstract level. All right, so now let's get into the code and create this logic for our application. So let me get back to the application, and here I go to the auth resolver, and we need to create another mutation for this resolver, and it is going to be sign up. So here I'm going to create another mutation. So mutation, and here we need to return the three values: the user ID, the role of the user, and the JWT access token for that user. All right, in order to do that, we're going to create another object type. So here in the auth directory, I'm going to create a new directory. I'm going to call it entities, and inside it, I'm going to create an auth-payload.ts. Okay, here we are going to create a class. So export a class. I'm going to name it auth-payload. All right, it is going to have an ID, actually a user ID, which is going to be number, and a role of the user, which is going to be of type user role. So it should be of type user role enum. And finally, we're going to have an access token. I think we have a typo here, so let's fix that. Okay, and its type is going to be string. Now we need to mark it with the @object type. It's going to be imported from the NestJS GraphQL, and then we need to mark each of these fields with the @field decorator. Okay, so for the first one, we're going to pass a type function and return the int type of the GraphQL, and then here for the second one, we're going to use @field, pass the type function, and specify the role enum. enum. Okay, I've talked about how we can handle the enums in the GraphQL in the previous episode of this course. All right, so here for the last one, we just mark it with add field, and we don't want to specify the type function because for the strings, we don't want to do that. Okay, let's close the auth payload class, and here for the type function of the mutation, we're going to specify the auth payload. So the returning object of this mutation is going to be of type auth payload. Okay, now we are going to create a method for this mutation. It is going to be sign in, and we need to have an argument here. So I use args decorator. I just name it input so we can have it in the parameter of the function, and we are going to set its type to the sign in input. I think we don't have a sign in input, so let me quickly create a sign in input here. I create a DTO directory inside the auth module, and inside we are going to have sign in input.ts. Okay, so here we're going to export a class. I'm going to call it sign in input, and it is going to have a email. We can just use username. It's up to you. So for example, let's say we are going to sign in the user with its email and password. So I just use email. It is going to be a string, and the client should have password inside the input. So email and password, it's a input type, so we need to mark it with input type. Okay, and using the add field decorator for both of these two inputs. Okay, add field again, and we can enforce some validation here. Use add isString and also add isEmail for the email. Okay, and for the password, we're going to use add isString and min length and pass 1 here. So the client must have a password inside its input. It can't be null, and actually we enforce the user to have a password inside its request. All right, so now let's get back to the auth resolver and the sign in mutation. We are going to set the input type to the sign in input type that we have just created. Let's put a body for this function. And now we can write the body here. Let me get back to the diagram here. As you can see here, we have two steps, the user validation and also the token generation. So first, let me implement the user validation. We need to look through our database to see if such a user is existed or not. So here, I'm going to say const user, and we're going to create a method in our auth service, and I'm going to call it just validate local user. So wait this .auth service and then validate local user. And then we need to pass the input inside it. Now let me just mark this function with async here, and then we can declare this validate local user inside the auth service. So let's go to the auth service here and just cut the validate user and paste it here at the end of the auth service class. First, let me mark it with async and just remove this exception, and I'm going to call it validate local user, and this is because of the user is a local user. It means that the user is kept inside a local database. The user does not come from a OAuth provider like Google provider or other OAuth providers. So that's why we call it a local user. So now we need to look through our local database with type-orm to see if the user is existed or not. So first, let me just destructure the sign-in input and get the email and password out of it. Okay, now here I'm going to say const user and use the user repo here. So this user repo find one or fail, and then pass the email inside it. So it will actually try to find a user based on this provided email. If it finds such user, it will return it. Otherwise, it will throw an entity not found exception. And if you have watched the previous video, we have created a exception filter here, entity not found filter. We are globally listening for entity not found errors from the type-orm. And if such an error is thrown by the type-orm, globally catch that error. And then instead of returning this error back to the client, we are going to return a new not found exception error, which is a regular HTTP not found exception. So here in the auth service, if such user does not exist in our database, we are going to just return a not found error back to the user. So if we find that user, we need to check the password of the user. So since the passwords are hashed in our database, we need to use the verify function of the Argon2 package in order to actually compare the provided password inside the sign-in input with the hashed version of the password that has been saved in our database. So in order to do that, I'm going to say const password matched and set it to await, and then call the verify function of the Argon2. In the first parameter, we need to pass the hashed version of the password, which is come from the database. So user.password is the hashed version, all right? right? We didn't use the await before the find one or fail function. So now we can just remove this await here, okay? And then in the second parameter, we just need to pass the plain password that we've got from the sign-in input. All right, now we can check if the password match is false. We are going to throw an unauthorized exception back to the user. So here, I'm going to say if not password matched, we are going to throw a new unauthorized exception back to the user and say something like invalid credentials, okay? And this is a very important tip here. Do not forget to put the await before the verify function. Otherwise, it returns a promise, and when here we are going to check password match function, it is a promise and it always have a true value. So if the user provided a wrong password, we just skip this exception trap and the user will be logging with a wrong password. So here it's really important to put the await here, otherwise we've got a really bad bug in our application. Okay, now if we skip this exception trap, it means that the password of the user is matched, so we just return the user, and this means that the user validation was successful. Now let's get back to our diagram tool. Here we need to generate the token for the user. So for the token generation, we are going to use the NestJS/JWT module. So let's get back to the VS Code here and let's open up the terminal. Let's close this up. We are going to install the NestJS/JWT. So at NestJS/JWT. All right, I'm going to install this package. You also need to install the config module with your NestJS application, but since I have already installed the config module, we don't want to do that. If you're not familiar with the config module, I highly recommend you to see the config module episode of our NestJS full course. All right, so I installed the JWT module of the NestJS, and now we need to configure the JWT module. But before doing that, let me go to the env file, and here we are going to create two env variables. The first one is going to be JWT secret, and the second one is going to be JWT expires in. All right. For the JWT secret, I'm going to use the OpenSSL to create a secret key for us. So I open up the terminal again and use the OpenSSL command. I'm going to create a random and -hex. Then we're going to use the 32 bytes, which means that we are going to create a 256 bits secret key. Here, as you can see, it creates the secret key for us. I just copy that and paste it here for the JWT secret. And for the expires in, we are going to set the expired time of the JWT to, for example, 60 minutes. Right? Let's save this. And now I go to the auth module here. And here inside the auth module, we're going to configure the JWT module. So in the import list here, I'm going to use JWT module. As you can see, it comes from the NestJS/JWT, and we're going to use the register async function. And here in the register async function, we need to pass a use factory function, and inside the use factory function, we need to return an object that is the config object for the JWT module. It should contain a secret and expires in options for the JWT module. So here we're going to pass a config object here and use factory. It is going to be a async function, and inside this function we are going to access to our env variables. So for accessing the env variables, we are going to use the config service, but in order to access to the config service, we need to actually inject the config service into this JWT module. So first we need to import the config module. Here we can use import list here and pass the config module, which comes from the NestJS/config. If I go to the app module here, you can see we have already configured the config module, and we also need to set is global to true, so we don't need to configure it inside the other modules. So let's get back to the auth module here. We import the config module, and then we are going to inject the config service of the NestJS config module. So I use the inject list here, and inside it we are going to use the config service. Now the config service is going to be injected into this module. All right, so now we can use the config service here in the use factory function. So I'm going to say config service, set its type to the config service class from the NestJS/config. All right, now here we're going to return an object, and in this object for the secret we are going to get it from the env file. So it is config service.get, and then we're going to set the string type as the generics, indicating that the returning value is going to be a string, and then we are going to pass the name of our env variable, which is going to be JWT secret. All right, we also need to specify the expires in, so we need to set the sign-in options, and inside the sign-in options we are going to specify the expires in, and again, we're going to get it from the env file. So I use the config service and get function, and this time I think its name was the JWT expires in. All right, get back here and paste the name of the variable here. Okay, we have a typo here, so let's fix that and copy that, and also fix that here inside the env variable. Okay, we have an error here, and that's because we need to put a comma here. Okay, so in this way, we can configure the JWT module with the env variables from our env file. All right, again, if you're confused about the using config module here, you can watch the config module episode of the NestJS full course, and you will understand deeply what is the config module and how it works. So simply put here, with config module, we are going to access to the env files and env variables in our NestJS application. So we use the config module here. You need to install it from the nestjs/config. Otherwise, you cannot access to the env variables inside your NestJS application. All right, so we configure the JWT module, and now we can use it to create the JWT access token. So now we can go to the auth service again and create a method for token generation. It is going to be an async. I'm going to name it generate token, and it takes the user ID as the input. So user ID is going to be a number, and here we need to create a payload for the JWT. So const payload. Okay, we're going to create a type here for the JWT auth payload. So here inside the auth directory, I'm going to create a types directory, and then we're going to create auth-jwt-payload.ts. Inside it, we are going to export a type. I'm going to call it auth JWT payload. Okay, and it is going to have a sub property inside it. And actually, inside the value of the sub property, we are going to put the data that we are going to embed inside our JSON Web Token JWT. If you're not familiar with the JWT, you can go to the JSON Web Token site and see what it is. But here, simply put, inside the sub property, we are going to put our data that we are going to embed into the JWT. So we just need to put the user ID inside it. For example, we can define a user ID here, and it is going to be a number. So this is going to be the shape of the sub inside our payload. Now let's get back here and set the type of the payload to the auth JWT payload, and it is going to be an object. Inside it, we're going to have sub, and in the sub, we're going to set the user ID and set it to the just user ID that we've got here in the parameter. All right, now we can use the JWT service to create the JWT access token. So first we need to inject it to this service. Here in the constructor, after the repository, we are going to inject the JWT service. So private read only JWT service, and set its type to the JWT service class of the NestJS. So here, as you can see, we have a JWT service which comes from the NestJS/JWT. Okay, now let's save this and get back here. So here in the generate token, we can have an access token here, const access token, and set it to await this.jwt service dot sign async, and then pass the payload object. The sign async function will actually use the configuration that we have set it up inside the auth module. You can see we configure the JWT module with this default JWT secret and this default JWT expires in. So we don't need to provide the JWT secret and JWT expires in variables here in the sign async function. It will use the default ones that we configure in the auth module. Okay, so now this is the access token, and we can return it inside an object here out of this function. Now we are going to create a login function. So here we're going to say async login, and this login will take a user object. Its type is going to be of type user entity, and then it actually return a promise, and it finally resolve to an auth payload entity. So you can see it should have a user ID, role, and access token inside it. All right, now first we are going to call the generate token function to get the access token. We'll say const await, now an empty object, await this.generate token function, and pass the user ID inside it. So user.id, and then we can get the access token of the returning object. Okay, now we need to return an object of type the auth payload. So as you can see, we need to specify the user ID and set it to user.id. Okay, we need to pass the role of the user, set it to user.role. Okay, and finally we're going to put the access token to it. All right, now we can go to the auth resolver here. And after validating the user, we are going to call the login function and actually return the returning object of the login function. So here, return await is the auth service, the login function, and just pass the user that we've got from the validate local user function. All right, it will actually return a auth payload object, which contains a user ID, role, and the access token. All right, so this is the whole process of our sign-in. Now let me run the dev server, npm run start dev. All right, the application is running, and let me get back to the playground. Now let me create a sign-in mutation. So mutation sign in, we need to pass a input, and inside the input we need to specify the user and email. So just copy the email here and put it here in the sign-in input, and for the password just put the 123 as a string. Now, from the returning object, I'm going to get the user ID, the role of the user, and also the access token. Okay, so let's run this mutation. As you can see, now we have a user ID, the role of the user, and this is the access token of the user, right? The client should keep this access token in a safe place, and then in the subsequent request to the GraphQL API, if it is going to call a protected query or mutation, it should include this access token inside the header of its request. I'm going to show you how you can do that. But now first, we need to use the passport package for protecting the queries and mutation of our GraphQL endpoint with the JWT. So we're going to use the passport JWT strategy package. Okay, so if you're ready, let's get into it. All right, so now let me show you the whole process of the JWT authentication with the Passport JWT library for our GraphQL endpoint in the NestJS framework. So let me little zoom in here. After the client gets its JWT from the sign-in mutation, it should actually keep the JWT in a safe place. And then, for example, let's say the client wants to call a protected query or mutation. We need to have a JWT guard middleware. The request of the client first goes through the JWT guard, and the JWT guard activates the JWT strategy of the passport. Then in the passport JWT strategy, we are going to extract the token out of the request object, and then we are going to verify the token with the same secret key that we have created that JWT. Also, we need to check if the JWT is expired or not. So if the JWT is valid, we are going to validate the JWT user. It means that we are going to extract the user ID out of the JWT and then look through our database to see if we have such a user with that user ID. So for example, if the user is somehow deleted from our database, we can throw an unauthorized exception here. Then after validating the JWT user, inside the JWT strategy, we are going to append the user object to the request object. Then here we can grant the access to the GraphQL protected resources, protected queries and mutations. So I'm going to show you how you can implement this whole process with the Passport JWT. And also I'm going to show you how you can access to the user object and extract the user object out of the request object inside your protected GraphQL queries and mutation. And here keep in mind that it's a little different to protect your GraphQL resources with the Passport JWT from the way you protect your REST APIs with the Passport JWT. So don't worry, I'm going to show you every detail you need to protect your GraphQL resources with the Passport JWT. So that was the whole process of the Passport JWT authentication for your GraphQL endpoint in a very abstract level. And now first we are going to implement the JWT strategy and then create the JWT guard and then put them together in order to protect your GraphQL resources. So let's get into the VS Code and let me turn off the dev server. And in the first step, we need to install the dependencies in PMI passport library and password-JWT. All right, so let's install these two packages. Also, we need to install the types of the passport JWT. So npm i-d, it's a dev dependency, and then add types /passport-JWT. All right, let's install it. Okay, now we can use it in our application. So in the auth directory here, I'm going to create another directory and call it strategies. And inside, we're going to put our passport strategies. So we're going to create a JWT.strategy.ts file, and inside it, we're going to export a class, export class. I'm going to name it JWT strategy, and it should extend the passport strategy, which comes from the NestJS slash passport. Or we didn't install this package, so let me quickly install that. npm I at NestJS slash passport. All right. So you need to install 3 packages: the passport library, passport JWT, and also at NestJS slash passport. Okay, let's close this off. Now we can call the passport strategy function here. And here we are going to extend JWT strategy of the passport. So the strategy here, as you can see, it comes from the passport-JWT. And then we are going to put the body of the class. So the JWT strategy here is going to extend the returning class of the passport strategy function here. Also, make sure to mark it with injectable decorator here. All right, now we need to have a constructor here. And in the constructor, we need to inject the config service. It is going to be of type config service of the NestJS. So let me import that from the at NestJS/config and make sure to use private here. Okay, and let's put the body of the constructor, and also let's inject the auth service to this class. We're going to need this auth service, so let me just inject it here, auth service, and set its type to the auth service class. Okay, now here in the constructor, we need to call the super function, and we need to pass a config object. So here we don't have the autocomplete for the config object here. In order to get the autocomplete, I'm going to create a dummy instance of the strategy class. So const dummy, for example, and set it to new strategy, pass the config object to it. As you can see, now we have the autocomplete for the options. So we need to set the JWT from request and also secret or key, and also ignore expiration. Okay, so let me just copy this config object and let's remove that dummy instance and paste the config object here. Okay, so for the JWT from request, we need to specify from where we are going to extract the JWT access token from the request. So we need to use the extract JWT. And here we have some functions here. We're going to choose the from auth header as a bearer token. So the client should have the access token inside its auth header as a bearer token. I'm going to show you how you can include the access token in this way in your header of your request. And then we need to specify the same secret key that we have used to generate the access token. So we can use the config service here. We need to get it from the env file, config service.get. It is going to be a string, and then we are going to pass the JWT secret. It is the name of the env variable containing the JWT secret. Okay, now finally we need to set the ignore expression to false. So if the JWT is expired, we are going to block the client request to the protected resources. I think we have missed a opening parenthesis here. So let's put it here and the error is gone. Okay, so this is for configuring the JWT strategy. We need to implement a validate method here in this class. So validate, and this validate function is called after verifying the JWT token was successful. So if it is successful, the JWT strategy call this method here, and it actually provide the payload that it extracted out of the JWT token. So we can take the payload here, we can define a type for it. So if you get back to the auth service here, and here go to the JWT token, you can see we set the shape of the payload object to the auth JWT payload. So now we can set the same type here for the payload here. I'm going to set it to auth JWT payload, and now we can have it inside our validate function. So now we can get the user ID out of the payload. So here I'm going to say const, we're going to have a empty object and set it to payload.sub, and from the sub here we can access to the user ID. So now let me get back to the diagram here. The JWT strategy extract the token and verify the token under the hood, and then it calls the validate function, and inside the validate function we need to actually validate the user. So let me get back to the VS Code. Here we have the user ID and we've got it from the payload of the JWT. So we need to actually look through our database to see if such a user is existed in our database or not. So I'm going to create a method inside the auth service. So I'm going to say const user and call the auth service dot, actually we don't have the method here, so let me just put it here, and then we are going to declare it in the auth service class. I'm going to name it validate JWT user, and pass the user ID to it. All right. Now we can declare this method inside the auth service class. All right. Now let's go to the auth service class and cut it from the beginning of the class and paste it at the end of the auth service class. First, let me mark it with async. So async, and here, let's remove this exception. Now we're going to look through our database with the type program. So I'm going to say const user and set it to user repo point one or fail, and then set the ID to the user ID that we've got in the parameter. So we're going to create an object. I'm going to call it JWT user. We can define a type for it. So let's go to the types directory here and create another type file. I'm going to call it JWT user.d.ts. Okay. Let's export a type here, call it JWT user, and specify a object here. It should have the user ID inside it, which is going to be a number, and also the role of the user, which is going to be of type enum role. Okay, now let's get back here and set the type of the JWT user to the JWT user type that we have just created. And here we can set the user ID and set it to user.id. So we didn't use the await here. The await here, I always forgot to put await before the find or fail. Okay, now we're going to have the role of the user, and we're going to set it to the user.role. Right, now let me get back to the JWT strategy, and here we are going to return that user object. I'm going to call this user JWT user and then return it here from the strategy function. So this object, no matter what is the name, is going to be appended to the request object on the property name user. So then we can access to this object with the request.user. Again, it doesn't matter what is the name of this object here. It always will be appended under the property name user to the request object. All right, so now let's get back to the diagram tool here. So here, as you can see, we're done with the JWT strategy, and the returning object of the validate function will be appended to the request object. But now we need to create the JWT guard, which sits between the user request and our GraphQL mutation and queries that we want to be protected. So now let's quickly create the JWT guard for our GraphQL API. So get back here and I open up the terminal. Let's close this up first. Now let's create a guard here. So NestJS, which stands for guard, and I'm going to put it inside the auth module and then guards directory, and then I'm going to call it GQL-JWT-guard, then -- no spec here. So let's create this guard. Okay, as you can see, it creates a guards directory here, and inside it we have a GQL-JWT guard. Okay, actually we don't need to put the guard here. NestCLI will add the guard to the guard, so let's remove that. And now here, let me close the terminal. We don't want to implement the canActivate class here. Instead, we are going to extend the JWT auth guard here. So use extend here and call the auth guard function from the NestJS/passport, and then pass the JWT here, which is actually the default name of the JWT strategy that we have created in the previous section of this video. All right, now if we are going to use REST API, we're done with our JWT guard. But since we are going to use it for the GraphQL mutation and queries, we need to implement the get request function. Get request function get the context as its parameter, which is actually a regular HTTP context, but we need to transform it to a GraphQL context. So here in the get request, we are going to say const ctx, which stands for context, and then call the GQL execution context, which comes from the NestJS/GraphQL. So GQL execution context, and then call the create function here and pass the context that we've got here in the parameter. So it actually transformed the HTTP context to a GraphQL context. Now we can get the request out of the ctx object. So here we're going to return ctx that get context, and then we are going to return the req object, which is our request object. All right, so this is very important to implement this inside your JWT auth guard for GraphQL. Let's save this, and now we can go to our user resolver, and here let me protect some of the queries here. So let me protect this mutation here, update user. In order to protect that, we just need to use the @useGuards here and then pass the GQL JWT guard that we have just created. So now the client needs to have a JWT access token inside the header of its request. Let's save this and let me run the application. npm run start dev. Right, it's running, and now let's also save the JWT strategy. Okay, let's get back to the GraphQL playground, and here, for example, let me just update the user with the user ID 15. Here, let me just put the user ID as user ID 15. Now we just need to update the username of the user. So let's run this mutation. As you can see, we have a authentication strategy error. That's because we need to register that JWT strategy in our auth module. So we forgot to do that. So here, let me close the terminal and get to the provider section of our auth module and register the JWT strategy. Okay, let's save this, open up the terminal. Okay, now let's get back to the GraphQL playground and let me refresh the playground. Now let's run this mutation. You can see we've got an unauthorized error indicating that this mutation is a protected mutation and we need to have a access token inside our request header. So let's go to the sign in mutation and let's sign in again, get the access token here, just copy that, get back to our update user, open up the HTTP headers here. We're going to pass an object and inside it we're going to have an authorization header, and here we need to pass a bearer key here and then a blank space, and then we are going to paste the access token that we've got from our sign-in API. Also, I think we need to wrap this authorization key in a double quotation mark. Let's save this and let's run the mutation again with this request header. So again, we have a unauthorized error. Let me get back to the JWT strategy here, and here, let me just log the user ID here. If we get the user ID, it means that the JWT strategy is called and the user ID is extracted. Also, let me just log the JWT user here. Okay, so let's open up the terminal. All right, it's done. And let me run the mutation again, get back to terminal. So we've got the user ID, which is the ID of the user, but here we don't have the user. So let me get back to the strategy. The JWT strategy is working, but here we might have a problem with the validate JWT user. And yeah, here I forgot to return the JWT out of this function. So just return the JWT user. All right, now let's get back to the GraphQL playground and let's run the mutation here again. And as you can see, now we can access to this protected mutation and we have updated the user successfully. But now let me just tamper with this authorization key. Let's remove the first letter of the access token and now let's run the query again. And as you can see, immediately we've got an unauthorized error, which means that our access token is not valid anymore. So let's put it back in the authorization here. Let's run the mutation again. And as you can see, now it's working. So yeah, that's it, the way that we can protect the queries and mutations in our GraphQL API. First, we need to create a JWT strategy. Then we are going to create a GQL JWT auth guard, and we need to implement the get request function and convert the execution context to a GraphQL execution context, and then return the request out of the get request function. And this way we can access to the request object inside our JWT auth guard. And then we need to actually go to our resolvers and protect the mutation and query with the use guard declarator and then pass the GQL JWT guard. Let me just get back to the JWT guard here and just rename it. Let's remove the second guard from its name. Okay, let's save this and get back to the user resolver. It's updated. All right, that's it, the way that we can protect the mutation. And now let me just protect the user query. Just use guards, then pass the GQL JWT guard. That's it. Now let's go to the GraphQL playground, and here let me just call this query, which is now protected. As you can see, we've got an unauthorized, and if we just copy this header and go to the get user and paste it here and run the query again, you can see now we can access to the query. So yeah, in this way we can protect the queries and mutations in our GraphQL with the Passport JWT package. Now in the next section of this video, I'm going to show you how you can access to the request object and extract the user out of the request object in your protected queries and mutations. So in order to do that, let's say here in this mutation, update user mutation, we want to access to the ID of the user. So here, as you can see, we've got the ID of the user directly in the argument, but we don't need to do that. Now, let me extract the user ID directly from the request object. So I'm going to use @context decorator here and then get the context. All right, let me just import the context from the NestJS/GraphQL, and then here we can get the user ID. So I'm going to say const user ID and set it to context.request.users. So let me just set it to user object, and here let me just log the user first. Okay, and here for the user ID here we can get it from the user.id. Let's save this, open up the terminal. All right, we don't have any error. Now let's go to the update user here, and now we should not put the ID here. The ID will be extracted from the access token that we feed inside the authorization key in the header of the request. So let's run the query again. As you can see, it is running. Now here in the terminal, you can see we have the user object here, the user ID 15, and the role is user. Let's go to the user service here, and we should set it to user.user ID, not the ID. All right, let's save this. And now let's get back to the GraphQL playground again, and let's run this mutation. You can see now the ID of the user is 15. And if I get back here in the terminal, you can see again, we have the user object here. So in this way, we can access to the user object here from the GraphQL context. But we can do it a little better. We can create a custom decorator and directly extract the user from the GraphQL context. So we don't need to use the @context decorator in our protected queries and mutations. So now let's create the custom decorator for extracting the user out of the context object. So here inside the auth module, I'm going to create another directory and I'm going to call it decorators. And inside it, we are going to create a current user.decorator.ts, right? And here I'm going to use the create param decorator function for creating a custom parameter decorator. So here, in order to do that, I'm going to say export const current user and then call the create param decorator, which comes from the NestJS/common, and then inside it we are going to pass a callback. It takes two parameters. The first one is going to be data, which is actually the data that is passed to the decorator. In this case, we don't need to pass any data to the current user decorator, so I just set its type to the unknown. All right, in the second parameter we need to get the context, so I'm going to call it ctx and its type should be of type execution context. So I import it from the NestJS/common. Then here inside this callback, first we need to convert the execution context to the GraphQL execution context. So I'm going to say const GQL context and then use the GQL execution context that comes from the NestJS/GraphQL, and then call the create function and pass the ctx, which is this parameter of type execution context. It is actually a HTTP execution context. So we can call this create function to turn it to the GraphQL execution context. Then we can return the GQL context that get context, and then we can access to the request object, and from request object we're going to get the user object. All right, so we just return the user object that we've got from the request object. Now let me get back here, and here in the update user mutation, instead of accessing to the context, I'm going to just use the @current user decorator, and then we can access to the user here. I'm going to set its type to the JWT user type. Then here we can remove this line which extract the user from the context, so we can just log the user that we've got here from the @current user decorator. Now let me get back to the GraphQL playground, and let me go to the update user and run the mutation. All right, now let me get back here, and as you can see, we can access to the user object here in the terminal. Let me just rename it to make sure that it's coming from here. I'm going to rename it as current user and then set it to the user that we got from the current user parameter. Okay, so let's run the mutation again. All right, let's get back here and open up the terminal, and as you can see, we have the current user, we've got the ID of the user and the role of the user. So yeah, in this way we can get the current user in the protected queries and mutation, and this is going to be extracted from the JWT. And here keep in mind that if you are going to use this current user, your mutation or query must be protected with the GQL JWT card. Otherwise, this current user will return a null value. So that's it for the authentication part. And now we can move on to the next section of this video, in which we are going to implement the role-based authorization in our application. So for the role-based authorization, first we need to create a custom decorator in which we are going to specify the required roles for each GraphQL mutation and queries. And then in the next step, we need to create a role guard in which we're going to check the role of the user with the specified required roles of that specific mutation or queries that client tries to call. So now in the first step, let me create a roles decorator in which, as I said, we're going to specify the required roles for each GraphQL query or mutation. So I go to the decorators directory in the auth module and then create a roles.decorator.ts. So when we call this decorator, we are going to call the set metadata function, which actually sets some metadata for a specific REST API route or a GraphQL query or mutation. So first we need to specify a specific key, and under that key, we are going to set the metadata. So here, I'm going to say export. And since we're going to need that key, we're going to export it from this file. I'm going to call it a roles key, and I'm going to set it to just roles. Okay, then we need to create the roles decorator. So const roles and set it to a function. It should take a list of roles. So we're going to have a roles, which its type is going to be a list of roles enum. Okay, let's import the role enum. And then here we are going to call the set metadata function, and we are going to specify a key. I'm going to pass the roles key here and then pass the roles that we've got from the parameter. So now let's go to the user resolver, and for the update user, let's say that this role requires the admin. So we need to put the @roles decorator. I think we didn't export the roles here, so let me quickly export it. And now we can use the roles decorator, and inside it we need to pass a list, and we can define the role.admin, for example. Okay, and since it's a list, we can say that this mutation can be run by the admin and also the user. So role.user. Okay, now let me get back to the roles decorator and put the rest operator here, so we can now use the roles here as parameter. So all of the parameter here will be packed as a role list, and then we're going to pass it to the set metadata function. But here's the problem: we can have a roles decorator without any role. As you can see, it doesn't give us an error. So in order to fix that here, we're going to say that it should have at least one roles inside it. So we're going to put it inside a list, and we're going to say that the first item should be of type role, and then we are going to spread the rest of the item, which is going to be a list of roles. And as I said, we need to spread them in this parent list here. So in this way, we can say that the roles is going to be a list of roles, but it should have at least one role inside it. So now, as you can see, we have an error, but as we specify one role inside it, the error is gone. So that's it for the set metadata function. We just specify that which role is required for running this mutation. We haven't enforced the role-based authorization. We just set a simple metadata with this query mutation. Now we're going to create another guard. So open up the terminal. Let me just close this up. NestJS, which stands for guards. It's going to be inside the auth, and then guards, and then it's going to be roles guard, and then -- spec. So let's create this guard. So if I go to the guards directory, you can see now we have a roles guard. All right, so let me close the terminal. Now here in this guard, first we need to extract the required roles that has been set by the roles decorator, and then we're going to check if the role of the current user is one of the required roles for that specific mutation or query. So in order to get access to the metadata of the request, we need to actually inject the reflector class. So here I'm going to use the constructor and private reflector. Its type is going to be of type reflector class, which comes from the NestJS/core. And now inside the can activate function, if we return true, we can allow the user to go ahead and access that protected resource. And if we return false, we just block the client request. Okay, so I just remove this return true here. We need to first get the required roles from the metadata. So here I'm going to say const required roles, and we're going to set it from the this.reflector.get all and override function. We can specify a type here. We are going to say that the value that we are going to get from the metadata is a list of roles. roles. So if I go to the roles decorator here, you can see we set the type of the value for the metadata under the roles key is going to be a list of roles enum. So we're going to set its type to the list of roles enum, and let's import the roles here. And now inside the function, we need to specify the key that we are going to get the metadata from that. It is going to be this key that we specified here. So we set the metadata under this key, and now we need to retrieve them under the same key. So let me specify the roles key here. That's why we exported from the roles decorator. And then we need to specify from where we are going to get the metadata. So first, we're going to say that get the metadata from the handler. And if it's not on the handler, which means the query or mutation, look for the metadata from the entire class. So the context.get class. We can put the roles decorator on the entire resolver class. Right now, here, we're going to check if the required roles is undefined, which means that we haven't set the roles decorator for a specific route. So we can just return true and allow the client to go ahead and access that protected resource, no matter what is the role of that specific user. So we just check if not required roles, which means that the required role is undefined. We're going to just simply return true. And as I said, allow the client to go ahead and access that protected resource. Otherwise, if we have some required roles, we need to get the user object, check its role to see if its role is one of the required roles or not. So first we need to get the user. It is going to be a GraphQL. So first we need to convert the context to a GraphQL execution context. So I'm say const ctx and use the GQL execution context, call the create function, pass the context, which we've got from the parameter of the can activate function. And then we are going to get the user. So here I'm going to say const user, set it to ctx.get context. All right. And then .rec.user. So we're going to extract the user out of the request object. It's an important tip here. We should use this roles guard only with the queries and mutation that are protected by the JWT guard. Otherwise, we cannot access to the user object inside the request object. All right. So the query and mutation must be protected in order to get access to this user object. And by the way, if the query or mutation is not protected in the first place, it does not actually make sense to enforce the role-based authorization on that specific resource. It should be protected, and then we're going to check if the role of the user is one of the required roles or not. So now we're going to check if the user role is one of the required roles. So I'm going to say has required roles, and we're going to use the required roles .sum function. It loop through all the required roles that we've got here from the metadata of the resource. So we're going to loop through them, and we're going to return user.role equals to specific role that we've got in this sum function. So if at least for one of the roles inside the required role, this condition holds true, which means that the role of the user is equal to one of the roles inside the required roles, we can allow the user to go ahead and access the protected resource. Otherwise, we should block the client request. So we just simply return this has required role. If the has required roles is true, we can allow the user to go ahead. Otherwise, we can block the user. So now let me go to the user resolver here. It is already specified with the GQL JWT guard. And now here, we're going to use the use guards here and put the roles guard. Okay, so the required role is admin, so only admin users should access this role. Now let's open up the terminal and run the application. Okay, now let's get back to the GraphQL endpoint, and the type of the user is user, I think. So let me just call the get user function, pass the user with the ID 15 to see the role of the user. Oh, it's unauthorized. That's because the access token is expired. So let's run the sign in, get a new access token. The ID of the user is 15 and the role is a normal user. So it should not allow us to run this mutation with this access token, which belongs to a normal user. So let's paste it here. Okay, let's run the query. As you can see, it says forbidden resource, and yet the role-based authorization is working. Now let's get back to the VS Code here and set the role of the user to be user. Okay, let's open up the terminal to see if it's working. Yeah, let's get back to the GraphQL playground. Now the required rules of this mutation is a normal user. So let's run the query. As you can see, now it is working since the role of the user is user and required rules is also a user. Now let me just update the role of the user. So here in the update user input, we don't have any role. Let's get back here and go to the update user, and here actually let's copy that and go to the update user, and here let me just put the role enum inside the update user input. Let's import all of the missing imports, and now we can have the role inside the update user input. All right, so as you can see, we can have the role, and let me set the role of the user to the admin, and from the returning object, let me just get the role of the user. So let's run this mutation. As you can see, the role of the user with the ID 15 is admin. Now let me get back to the user resolver and set the required role of the user to be admin. And now let me get back here. And if I run this again, it should run without any run, as you can see. Yeah. So let's rename the name here. Okay. So as you can see, it is working because the role of the user is now admin. So yeah, that's it, the way that you can implement the role-based authorization with your GraphQL queries and mutations. But here, this is a very important thing. The GQL JWT guard should be closer to the mutation, because when we declare this function with a declarator, this whole function will be fed to this declarator as a callback. So first, the GQL JWT guard will be applied, and it will append the user object into the request object of the request. And then this whole section will be fed into this roles guard as a callback. So it means that first this guard will be applied, and then this guard will be applied. So if we just change the order, we get the error, because here in the rules guard, when we are going to access to the rig.user, the user object will be undefined, because here the roles guard will be runs first, and since the GQL JWT guard has not been applied yet, the request object does not have a user inside it. So now if I run the query again, as you can see, it says that do not read properties of undefined, because the user object is undefined. So let's fix the order of the use guards. So again, your JWT guard should be closer to your function, and then use the roles guard above the JWT guard. So yeah, that's it for this video. And in the next episode of this course, I'm going to show you how you can apply advanced TypeScript technique with your GraphQL resolvers. And I'm going to show you how you can use paginated queries. And in the next video after that, a long video will be uploaded in which I'm going to clone a blog project with NestJS in the backend, NestJS in the front end, and use the GraphQL as an interface between the NestJS and NestJS projects. So it is going to be a monorepo of these two projects. So yeah, if you like this video, please hit the like button to give me more energy to create such a tutorials for you. And if you subscribe to my channel, that would be icing on the cake for me. I really appreciate your support, and this means a lot to me. See you in the next video. Have a nice time. Bye bye.